Now the third type of air pollution preventing equipment is your fabric filter. Now as the name is suggesting, fabric filter, that means the fabrics will be utilized as the filter media. Okay. Now as we people know that the fabrics will be having certain pores inside it, right? So these pores will be utilized in order to collect the suspended particulate matter which are there in the gas which is going to come out from the incinerator. So totally what we are going to do is, here we are going to use the fabrics, that means the clothes, as a filter media in order to collect the, or in order to remove the suspended particulate matter which are there in the gas. Okay. Now as you know, this is how the construction of the fabric filters has been done. Here we are going to have the hangers. To this, what we are going to have is, we call it as a manifold. To these manifolds we are going to attach these fabrics, okay, which is going to have the diameter, right? This is having, you can see that here, you can see that this is going to have the tabular filter. Okay, these are having the tubular shape. That means it is going to have the diameter of around 12 to 40 centimeter dia. These are vertical in shape. This is 12 to 40 centimeter dia they are having, and they are having 2 to 10 meters long. Okay. Now these have been attached to the fabrics, or these are attached to manifolds. These are going to remove the materials or the suspended particles by the method of inception, inertial compaction, diffusion, and electrostatic attraction and gravitational settling. By using all these, it is going to remove the suspended particle matter which is there in the gas which is going to come out from the incinerator. Okay, so here what we are going to have is, first it is the dirty gas. See here there are two openings. They are being arranged in a one particular line. They have been arranged. From here what they are going to have is, from dirty gas here it is going to enter, and here there is a baffle wall. Okay, this baffle wall will prevent the direct entry of these suspended particulate matter or the smoke entering into the fabric. Here there is a baffle wall, so it is going to hit these particular baffle wall. The gas is going to hit the baffle wall. It is going to flow downside from this particular area. Then it is going to enter these fabrics. Now fabrics will be, as I have told, the fabrics will be having the pores. Now in these pores, these suspended particulate matter will be getting arrested inside these particular fabrics. Here we are going to get the clean air. The gas will come out from here. It is going to enter. Your baffle wall is there. It is going to prevent the entry. Then the polluted gas will be coming from here. It is going to enter into these tabular filters. Okay. Now it is the suspended particle is going to be collected over here, and ultimately you are going to get the clean air. Now there is a cleaning process is also required in particular in these particular your fabric filters. Okay, and here there is an hopper is there which is having the conical shape. Now whatever the larger suspended particles or the larger particles, right, if it is there, if it is having a very fine dust, it is going to enter into these fabrics, and the particles which are going to have the greater size, they will be getting collected over here into these particular hoppers. Okay, and here at the end we are going to get the clean air out. Now the maintenance is also going to be required in these particular filters. If these filters are clogged, they cannot clean the polluted gas. So we require a maintenance work. So how we are going to maintain it? Now we are going to remove the suspended particles which has been arrested into this particular fabric. We are going to clean it by the process of wrapping, shaking, and with the vibration, and by reverse airflow we are going to have it. Now what is wrapping? Wrapping and shaking is nothing but when we are going to vibrate here, right? Mechanism for shaking or wrapping or vibrating is, here we are going to vibrate. Once we are going to vibrate these manifolds, what is going to happen? right? The suspended particles which are getting arrested into these fabrics will be getting collected downside, and here it will be collected from these hoppers, right? So this is with the help of wrapping and shaking. Okay, now what is reverse airflow? From here the dirty gas is used to enter, and clean gas here we are going to have it. Now during the cleaning process, what we are going to do in these particular fabric filters is, in the reverse airflow we are going to have, during the cleaning process, the air will be coming from this end, and we are going to use a very higher velocity. Due to this particular higher velocity, what is going to happen here, some amount the air is going to enter, and again we are going to get the arrested suspended particle we are going to getting collected here. So this is regarding the screening of your operation and cleaning of your fabric filter. Okay, now we'll discuss the operational problems that we are going to face in fabric filters. Now, since the suspended particles are there in this particular gas, there is a frequent clogging of these particular fabrics will be occurring. So we need to have the repeated cleaning for these particular filters. Now, next is, since we are going to have the vibrating or shaking, now these fabric filters may get tear. Okay, and the one more problem is, we cannot use the gas inside these particular fabric filter the temperature more than 300 degrees Celsius. Since we are going to use the fabrics of a special quality, we need to restrict the gas that is going to enter into these particular fabric filter up to the temperature of around 300 degrees Celsius. Next problem is, if very fine suspended particles are there in this particular fabric filter, if it is going to enter, we cannot remove those suspended particles, and sometimes the hygroscopic dust is going to create a problem. Okay, it is going to have some effect on these particular fabrics. Next is chemical attack. When the gases are going to have the material, or the gases like SO2 and all, it is going to come, it is going to create a problem in these fabric filters. Okay, now applications. Now we can use these particular fabric filter where metallurgical industries, foundry industries, cement industries, chalk and lime industries, then brickworks, ceramic industry, all these will be in all these areas, floor mills, all these areas we can use these particular fabric filter. And whenever we are going to enter the gas inside these particular fabric filter, we need to maintain the velocity of those gas particles at around 0.5 to 1 meter per second of the 0.5 to 1 meter per minute of the velocity we need to maintain inside these particular fabric filter. And efficiency during the pre-coat formation, that means when we are going to enter the fresh air after cleaning, if we are going to enter the fresh air inside these particular fabric, at that particular point the efficiency of the suspended particulate matter removal will be very much higher, because as it is, the pores are clean, or it is not going to have any suspended particles into it. As we are going to enter the suspended particles inside it, since the pores are open, they are getting arrested. And as the time passes, what is going to happen? Since the pores are getting clogged, whatever suspended particle we are going to enter, they may enter into these fabrics, but they may not getting collected into the clogs. Why? The clogs are already closed. So this is due to that, during pre-coat formation, the efficiency is high. Later on it is going to reduce. This is also one of the disadvantage of this fabric filter. Now next we are going to discuss regarding the scrubber. Now we will discuss regarding the scrubbers. In scrubbers we will be discussing regarding spray tower, vertical scrubber, cyclone scrubber, packed scrubber. Okay, now scrubber means we are in order to remove the suspended particles which are present in water, we will be using the water media in order to remove the finer suspended particles which are present in water. We are going to use a water media. See, when the dust particle are going to pass through the water media, right, the dust particle will be attracted towards that particular water media, and the water media will remove these suspended particles which are present in water. Okay, so this is the main concept behind these scrubbers. Now scrubbers, they can remove the particles in between, having the size of 0.1 to 200 micrometers, right? They can very effectively remove. Okay, so this is the basic, this is how the particle will be getting removed. The water droplets, when it is there, it is going to come in contact with the suspended particle. The water media will attract these suspended particle, and then they are going to remove the suspended particle. This is the idea behind all the scrubbers. Okay, now we will see the spray tower. The first type we will be seeing it, right, regarding the spray tower. Okay, now the towers are very effective in removing the particle of around 10 micrometers. Okay, these spray towers are very efficient in removing the particle of 10 micrometer. Now here this is the setup of your spray tower. In this spray tower, the dirty gas will be entering into this particular the scrubber from downside, and here from top the liquid is going to be get sprayed. Now since the gas is there, it will try to flow like this upwards, but as the water droplets are coming, what it will do is the suspended particles it is going to attract and it is going to settle down. Now here we are going to get the clean gas we are going to get at the top. This is regarding the spray tower. Now the next is your Venturi scrubber. Okay, here your Venturi scrubber is efficient in removing the particle in between 0.5 to 5 microns diameter. Okay, and it is going to be used for sticky gases, sticky kind of a gases we are going to use, and we are going to have the speed of around 60 to 120 meter per second. Okay, the main thing that you need to keep in mind is, in the Venturi scrubber we are going to use a very high velocity gas at the rate of 160 meter to 200 meter per second we are going to use. It will be entered here, and here as we can see the area we have got reduced. So here with the more velocity the gas will come. Since it is going to have the very higher velocity, it is going to form the double vortex, and here you are going to spray. Okay, spray the water to this, and then the pure gas will come outside. Okay, this is the idea behind your scrubber, cyclone scrubber. Next is your cyclone scrubber. For cyclone scrubber, here it is we are going to allow the gas in the cyclonic motion, as we have seen in the cyclone separator. Here also what we are going to do is, from here we are going to enter the gas with a very high velocity. It is going to enter into this particular cyclone scrubber, and here the water will be getting sprayed down. Clean water will be coming out from here. Here there is one column we have made, and this will be rotating. Okay, this particular column will be rotating, and it is going to spray the water. Here the gas will come like this way. Okay, and the water will come from this particular column, and it will be rotating the water. As the water is coming, it is going to attract the suspended particle coming from this particular inlet. The dirty water will be collected here, and we are going to collect the clean water outside. Now next type is the packed scrubber. In the packed scrubber, we are going to use the packing material like stone, coke, right? We are going to use, and we are going to have the column of that. Right here we are going to have the fiberglass or coke or broken stone we are going to have, and from here from downside we are going to pass the dirty gas, and in between we are going to have these water spray. Now the gas want to move like this. but as it is getting filled by the glass, broken glass, and your coke, right, stone, the suspended particle will be getting arrested into this, and then since we are spraying water, these suspended particles, the dirty water may be collected here downside, and at the top we are going to get the clean air into the packed scrubber. Okay, this is regarding the different types of scrubber we are going to have. Now we'll see the advantages of the scrubbers. Okay, we will discuss the advantages regarding the scrubbers. The scrubbers will be having the low initial cost, moderately high collecting frequency, as it is going to collect the particle from 0.1 microns, all are also getting collected. Then application for high temperature installations, we can use it at a very high temperature gases also. They can remove the gases simultaneously. Okay, and then the disadvantages are the high power consumption. These are going to consume high power. Then moderate to high maintenance cost are required in, and there is a problem of corrosion and abrasion may be also there. Why is corrosion? Is the various kinds of gases, if it is going to have the SO2, the oxides of sulfur and all, it is easily, it can react with the iron. If it is casted with the MS, then it is going to be getting corroded. Okay, then wet disposal of collected material. The water that we are going to get from these scrubbers it is dirty. It is going to have the suspended particles in it. Now these suspended particles have to be collected downside, right, in order to operate these scrubbers continuously. So it is going to give you the continuous wastewater. Huge quantity of water is getting wasted, and it has to be recycled with the adequate treatment. These are some kind of disadvantages that we are going to have with the scrubbers. Now in the next is we are going to see the electrostatic precipitator in the next class. Okay.